next speaker, his fun fact, and I thought this was kind of cool, was when he was in the Navy, that's the one with the boats, he was on one of the boats that responded to the Captain Phillips incident. Yeah. My follow-up question was, yeah, give him applause for his service. They deserve it. My follow-up question was, were you in the movie? And his response was not even close. But anyway, oh my God, I forgot to ask you how to pronounce your last name.
Ski.
Tim, everybody.
Yeah. Hey everybody, my name is Tim Ski, and I'm part of the Tech Fellows program for Capital One. And I just want to say that I've learned so much being here, and it's just really awesome. I'm glad to talk, even if it's right before lunch. And so I just started programming in Go seriously about a year ago. And at work, when I'm not building container infrastructure and doing some Go at work, I write a lot of Go in my free time. And I really wanted to show you my experience of kind of building this like weird kind of platform in Go. But ultimately, since it's only a 20-minute talk, it's only a small sliver. But so I come from the Python background, and I am one of those non-CS college graduates, or actually I've never been to college. So obviously, this should give you some perspective. And so really, I had two goals when I started, which was I wanted to learn Go, or at least learn it better. And essentially, I just wanted to get my dog, Skeeter, more followers on Instagram. It's basically my two motivations of this weekend project that I've been building in my free time. And so the grand vision of this thing was I was going to build this serverless platform to run Go functions in Docker containers, which I thought was pretty cool, pretty ambitious, and still kind of new to Go. And so part of learning Go was when I would write some code, I would typically pull in some libraries and some other things. And I wasn't too intimate with the standard library and some of the other internals and kind of how do you solve certain particular problems in Go. A lot of it was already abstracted away from me, so I really wanted to spend more time and just get more intimate with the language and stuff like that. And so really in this particular project, I just had to do two things really well, which was run Go functions and just kind of a generic container task runner, essentially, is what I had to build. And so when I first built this thing, it was a blocking distribution execution engine that would just run Go functions on demand, which kind of satisfied at least most of the requirement, but I wasn't very happy because why would I use concurrent language? And it's all these other things if I had blocking. And so my hardest problems with this project, or like my hurdles, was like, how do you run just a Go function? Understanding mutexes, I've never written a mutex before, so for me that was a very hard problem or something to just kind of get over in the beginning was like understanding what mutexes were. And the global and local scheduler state. And so when I allocate a task for the cluster, whether I have an on-demand job or a batch job, I have to be conscious of those workloads of not over-allocating tasks. And so I have state both in my server and my worker nodes in the cluster, and keeping state of what is doing what and not overriding it or not over-allocating, that was a pretty hard problem for me to solve. And so I got really excited about a month ago or whenever Go 1.9 came out because they came out with the sync map package. And I got really excited because one, that was another thing to learn in the standard library, and two, I thought it was going to solve all of my problems and it was going to be amazing and probably better and faster. And the reality is when I looked at the release notes, there wasn't much there. And I looked at the comments in the code, there was some things, but they basically told you don't really use it. And then when I looked at GitHub issues, they basically told you you shouldn't use it. I looked down Reddit, they said you probably shouldn't use it. So then I was like really kind of upset. I was like, man, I was really pumped about this thing. Everybody tells me don't use it. But then I was thinking like, I think I might have a use case where this may be useful. Because this could potentially be a large distributed system that can run a lot of containers and be very big boxes. And so when I was looking at it, these were the functions that were exposed in the new map type in the sync package, which you have your load function, which basically is just getting or retrieving your map. You have your store function, which is setting or putting a new map, a load store, which is kind of like an update where it won't change the state of the map if there's no updates and it will return the actual. And of course, delete and range, which are pretty typical. And so looking at the map type, there was no surprise that there is a mutex there too, just like channels and a lot of other places in the code base. So I just wanted to show that it's just mutexes anyway. And so I basically just wanted to keep like some takeaways from when I was looking at this thing, that this is of course new as of Go 1.9. It's usually great for 16 plus core machines, which the key word here is usually. Right? It all depends on a lot of different things. What's ranted and raved is it's great if you have cache contention problems, which is also particularly hard to find if you're debugging or profiling. Obviously, there's worse type safety in this implementation, which is obviously what a lot of people do not want to use this for, is if they want to have type safety with their simple rewrite mutexes that they already have. And it's optimized for ranging over stable keys. Found and not found are pretty much the same. And so in my implementation, I created this basic concurrent map type. I didn't use the concurrent maps external library, which does sharding and some other fancy things, because that defeated the purpose of learning Go or understanding what mutexes are or what they would do for me or how I can leverage them. So I created this type with a read-write mutex and, of course, a map to a pointer to my worker type, which is a struct. And I have a create, very simple, so just creating my new map. I have a delete, just like the sync map does, which just deletes my map. I have a get, which is retrieving or getting my map. This would be essentially the load in new sync map package. And so my worker type, I have a lot of different fields of data that I collect on the nodes, the worker nodes themselves. And these often change a lot. But so I circled the ones that change quite often for me, because the tasks could be when the local state is updating the global scheduler state. It could be when I'm allocating a new job. And that's pretty much when that will mainly change. And last join is basically every time a worker node checks in, which right now I set for every 2 seconds, that will change. And of course, the other fields will change if those other fields are updated. And so I have constant reads and writes that I have to be very cautious of. I have my dashboard, I have available work, I have healthy for work, Go routines. Is the worker alive? And then the writes is if it's a new worker node or if it's checked in, and then also any assigned work or reserving workload for that particular worker. And so when I'm scheduling the node for this cluster, I picked a really simple algorithm that basically just says, is there workers? Is the worker alive and healthy? Is the worker part of the right group? And group here is basically like a larger logical partition or some subset of the cluster that has only certain permissions to execute Go functions or any other functions. And then what worker is least being used in the cluster. And initializing these maps, this is what they very much look like. And so the store and create, they're called the same exact way. Initializing is very similar. This should show you like they're pretty much, from a user perspective and API perspective, they're pretty much the same. And so I ran this benchmark because obviously this is what I really wanted to find out. Like, is this thing useful for me? Obviously, I could have checked to see if I have cache potential problems, but ultimately, if I was going to make the investment, or if I think that sync map is going to improve by flattening their pointers, or some other types of means of optimizing their sync map package, at least I can make an investment now, and I'm only going to get benefits from here on out. And so one of the things I really noticed is part of the workloads that I do is I check to see if a map is available, and then I update that map. Right? So for me, that's 2 locks, and that's 2 calls. And so load or store function gives me that ability to basically do that same type of call with a new sync map package, and I get a lot of increase in performance. And so what you're looking at on the screen is you have 1 to 64 is the amount of cores I've ran this benchmark on. And I'm comparing the types of work of the platform that I built. What would be your typical found stable keys is pretty much like the use case here, because not unless they're being created or deleted, or I should say being created, those are brand new keys, but they pretty much stay stable the most of the time. And those values change as obviously workload is being scheduled or when they're being checked in. And so for me, what's an interesting thing here is because if I was going to write like enterprise software that I would eventually sell or something, what I've noticed in some companies is that they'll sell some sort of master node or some sort of large node, And it could be a 32 plus core system, but then they ran into a lot of bottlenecks. And obviously this was one of the motivations of having SyncMap around. So I think it's a really great container for my use case, and it could be for years if you're building a very similar system like I am. So I didn't build it all from scratch. I had to use some things, mostly purely by choice. I didn't want to reinvent the entire wheel, or at least have some things that were easier to change over time. And so for my HTTP router, I choose Gin. And for my system resources, I use psutil, the Go implementation report, the Docker client, and then for the file system, I used a couple of different libraries to help me manage my FUSE file system. I wanted to share a piece of information that's kind of not really on topic, but I thought was pretty interesting, was that when I was Googling around, I was like, hey, it takes me about 200 to 500 milliseconds to spin up a brand new container from a cold start. And to me, like, that's kind of like waiting in entirety. And some people are like, that's fine, that's cool. But for me, I was like, how can I get benefit of running particular jobs by shaving off that time? And so I didn't really find any blog posts or anything. So I figured I'd share with you that when you're running when you're creating a Docker container from scratch or from start, if you basically disable logging, that's totally up to you. Obviously, these are just what I've noticed. You'll save about 10 milliseconds on that initial start time. Disable networking, if obviously you're just computing some simple formula or something and you don't need networking, you can save 50 milliseconds. Enabling privilege mode, which isn't recommended but also can save you some time in starting. And then running in the host namespaces rather than the namespaces that Docker allocates you. And so really what I ended up with at the end wasn't not terribly like a serverless platform per se, but at least I have a non-blocking distributed execution engine that runs Go and Python functions both on demand and in batch using containers. And so that doesn't get me 100% to my goal, but at least it gets me close enough to where I'm pretty happy with the results. And I think it's pretty cool, and I'm going to give you a demo of that. And so this is the repository where the benchmark lives. So if you want to see that particular benchmark that I ran, this is the repo. And since this is a true story, my dog went from 96 followers to over 13,000 followers in 7 months. So I think that's a pretty successful thing that this Go project, helped me achieve. And of course was one of my initial goals of doing this. So I'm going to go over 2 examples of running a Go function inside the platform. I have an example Go package that I created that just uses a couple of standard libraries. And I have an add function, just takes in 2 integers and returns back those added. And the other example is I have this file that's going to be on disk that is read. The value in that file will be incremented by whatever I pass in, and then it will also write it back to disk after it is done, and it will return what the new value is. Right? 2 basic, really simple functions. And that file that you're going to see on disk when we're starting out will be 1. So every time I increment this file, it's going to increment through whatever the incrementation is. That's going to be just 1. In my platform, I have 3 nodes that are currently up and running. And the max amount of tasks is how many tasks I can currently run right now. Think of those as almost like how many containers can I have running on these nodes, and this is figured out based on the max amount of CPUs, the current tasks that are being run, average task time, and then available health nodes, and some other information about those nodes. But so if I were to basically oops, sorry. I'm basically going to loop over this command that says what package I want to run, the function with any arguments, and the language I'm choosing is Go for this particular example. you'll see that currently I'm running that Go function that I had showed you in the example package. And you'll see that the number 1 is bouncing between the different nodes. And so right now, all that's doing is executing that Go function on those nodes in the cluster. And I'm allocating that task, and the task is coming back. And these are on-demand executions. So I'm saying, hey, spin up the container, run the function, and then come back to me. And so I'm going to pause this really quick. And I'm going to change that function to just add 1. So now I upload a new function, and currently without any disruption to the service, or with anything, the function is executing within the cluster without any disruption or without any kind of magic in the cluster. And so I think that's pretty cool, that I don't really, like from a deployment perspective, I don't really have to like package things up or do anything. I just have a bunch of functions, and I can call other functions. And I basically just submit whatever my new code change is, and it takes to the cluster, and it currently is going to run the cluster. And I don't have to do anything about it, or package it, or include any special libraries to execute that function. And so that was one example. So I'm just adding those 2 numbers, changed the Go file, uploaded it, and now it's taken effect without any disruption, and it was running live. But so now if I want to increment on that file, which is pretty interesting because this is going to run on multiple different nodes and change that file. And I also do not want to see any disruption to the service. And so you'll see that the task is being run and the number is being incremented, which is pretty cool because there's no disruption, and I can do this within multiple nodes and change state on the local disk without having to do anything. And while this is running and it's incrementing, you'll see it'll eventually bounce around, but I could also even just kind of schedule something that will live for 120 seconds. And you'll see that that new batch is being run on that node. Another cool thing was, in this implementation, I did not use channels. It was just all a concurrent map. And so if I were to take something like, hey, and I'll let these jobs clear up for a second, but if I take something like, hey, and I say, I want to run 50 requests right now in 10 threads, and here is basically my payload to make the post request and into the URL. What's really cool is because in this cluster, I can only run, as of right now, 5 tasks because I only have 3 nodes. Each of them can only run 2 tasks at a particular time, and 1 is being taken. So because that is running, I could just say, hey, run this, and I should only be able to allocate 5 tasks, which I got 5 200s back. And so, which I think is pretty cool, because if I'm paying the system or I'm trying to allocate things, I didn't have to use channels or anything else to prevent over allocation of this. And then also, how do I also not make sure I don't run too much workloads on my local worker nodes via the local scheduler? And so that's pretty much it. What I wanted to share with you today with choosing that concurrent map implementation, some thoughts, benchmarks, and then also like what Chris said yesterday, I think Go is basically that language for the cloud and enabling systems to be built like this. And it's very super awesome because it only took me about 4,000 lines of code and some weekends that I had free and available. So I think it's pretty powerful. Is there any questions? Yes. Yeah, so
Can you repeat the question, please?
yeah, the question is, how did I use this to get my dog more followers? So I basically wrote a bot, and I call the main function to then go out to Instagram and get him, find them like minds, follow them. If people didn't follow me back, I just unfollow them because I don't want to follow those crummy people. And so I basically just run this in batch mode. And I just basically have one node to do it because it's only for me, but I also wanted to make sure that if I were going to extend this or have other people use it or maybe do some more advanced things, that it would at least be open and flexible. But so yeah, I run my dog's bot on this platform in batch mode. And I have this function called Skeeter run, and he runs all the time. Any other questions? Yes?
Is it possible to pipe the output from one containerized function into another? Have you considered doing something like that?
Yeah, I actually have. I mean, if you're purely on the shell, you're able to do that. If obviously I had no way to do that through the API to say, hey, run this job, whatever the output is, obviously if it's standard out, go to this job. I haven't built that, but if you're just using command line with the shift CLI that I built, you can definitely do that through just assigning a variable and then passing it to the next function. Yes?
How does the file stuff work? Like how can you write in one file from one container and then read it from another container?
Yeah.
You have to use FUSE, but that comes in.
Yeah, so the question was how was I able to write that increment file, like that regular file, how was I able to read from and write into it from different nodes without it going crazy or some crazy locking? FUSE handles a lot of it. Also, I had Cassandra to keep metadata on every time something is read or written to that disk, that metadata is carried to every single node so that the file looks the same everywhere. So there's a mix between FUSE and Cassandra to help me do that, and of course I had to write some layers on top of it. But FUSE is pretty powerful, and there's also a very small, tiny cache there also, which I implemented only because, using group cache, only because if I didn't have caching, it probably would fail, right? Because you are updating that file on the file system.
Hey, I think we have time for one more question, if we have another question. Anybody? Bueller?
Oh,
Oh, in the back.
How far down did you get with code start the
It all depends on the image
Can you
size.
repeat the question, please?
Oh, yes. So I mentioned it could take 200 to 500 milliseconds for the container to cold start. The question was, how far down did I get my container to start? That actually depends on the size of the container. If you're using just a regular Alpine image, it's quicker. If you're using the Python image, it's obviously going to be bloated, so the overlays that get created and everything else, it takes a while. But so I basically shaved off 100 milliseconds if I don't need networking, like doing that add function. I didn't need any networking, so I was able to shave 100 milliseconds off of that start time.
Awesome. Well, thank you very much, Tim. We
Thank you, Tim.
appreciate it.